Hello guys, it's Alex here, Victor Kilo 2 Papa Radio Charlie over here in Australia. Just put together another video in my series of videos concerning the Clansman 320 radio, and this one I'm going to be looking at something very interesting when it comes to the output power. Before we get into it, a little bit of a story. Before I start, you probably noticed this one's got a screen. It's got a DDS fitted into this one. This is my Clansman 320D Mark II. You can have a look at it and its creation on my YouTube channel. Okay, getting back to my story. The other day I was on another one of these, talking DX into a friend of mine, Ken, in Spain. Ken runs a trolley radio next to a salt lake and using a ground tuning unit and a quarter wave vertical. His call sign is EA5/G4VZV. Ken said to me something that rang a bell straight away in my head. Why does your signal always start off at 5.7 and as you talk for a little bit of time it drops down to about 5.4? And if I get a bit of QSB I miss some of the words in the back half of your long sentences. This happens continually all the time. Is there something wrong with your radio? When I heard that, I immediately thought of all of the notions and stories that I've heard about the Clansman over the years about how they drop down in power after about 5 seconds to save battery power and perhaps a bit of overheating on the PA stage of the output. But I've heard over all the years this doesn't happen on single sideband. This is only a CW thing. So don't worry about it. It doesn't happen on single sideband. But hang on a minute. This is not the first time that this has happened to me or someone's made a comment like that. So being an inquisitive sort of a person, I thought to myself, I'll set up the radio here into a dummy load and I'll do a few tests myself. And we'll just have a bit of a look at what's really going on here when it comes to this power reduction. So I've got the radio set up here into a dummy load. I've got a meter on here. I'm looking at the peak output voltage, and from that I can calculate power. I've got the radio set on high power, and I've got it set here. I'll put it onto single side. It's on CW. Okay, so let's have a bit of a look at this power reduction on CW. So I'm going to hit the button, about 36, dropping down to 24, 36 and 24. I'll just do that again. 36, dropping down to 24. Okay, so let's just have a look at what that actually means in power output on CW. Okay, so if we go 36 times equals divided by 50. When it's up high, the radio is putting out about 26 watts. Yep, so drop down to about 24. So 24 times equals divided by 50. Drops down to 11 watts. 24 to 11 watts. That's a huge reduction in CW. And I thought to myself, hang on a minute, I don't do Morse code, but I do hear it on the air all the time, and it's a series of dots and dashes. It's not a continuous tone. So why would they do that to a radio and say that it only happens on CW? Who would sit there with long tones on CW? I'm sorry, I don't understand that. So let's have a look on sideband. So I've gone up here onto sideband, still remaining on high power. Okay, but this time I've got no continuous talking. So what I'm going to do is, just to give me a sort of a reference, I'm going to go onto a tone generator. Okay, and I've got one here on my phone. There it is there, my tone generator. And I can actually generate a tone. And let's have a look at what happens to the radio when it's in high power on sideband. Okay, putting a continual tone into it. Okay, so here we go. Oh, it didn't work, I didn't put the tone on. Okay, there's the tone, here we go. 34, 35, dropping down to about 20, 29. Okay, 35 dropping down to 29. 35, dropping down to about, let's say 27. One more time. 35, 28. 35, 28. Let's just use those sort of figures. Okay, so we'll go back here to the calculator on the phone. Okay, 35 to 28. So 35 times equals divide by 50, putting out about 24 watts on single sideband. What did it drop down to? 29 or something. Okay, so let's go 29 times equals divide by 50, drop down to 16 watts. Wow, and that's actually happening on sideband. So if I have a long drawn out speech like I'm talking now, and I don't pause or go on, I just have a long sentence and I'm talking about this, that, and the next thing, I would expect the back half of my sentences to be clipped off or lowered down if this is all working out in practice, as it seems to in theory. Before we go on here, let's just have a look at the blueprint on the 320 and see how this happens. See what's going on as far as the circuitry is concerned. Okay, we've gone to the manual on the computer. We're looking at the power output section, which is unit 2 on the radio, and I found paragraph 9 describes the drop in power that I'm experiencing with the radio. So it says, a delayed mean control limits the power output under continuous tone conditions to approximately 4 dB below the peak envelope power to avoid excessive heat dissipation and power consumption. And that's really all it says, which is a little bit vague. It doesn't tell me how it does it. It just says why it does it. So it doesn't even say whether it relates to single sideband or not. It's just continuous tone conditions. Okay. All right. So we move down to the actual circuit. We'll have a look at the actual circuit and see where this could possibly be happening. So I've gone down here to the drawing. Just bear with me. Here we go. This is the PA section, 2 section of the radio. We'll look at the inputs. Okay, so here we've got the inputs into the card. The RF path is pretty distinct. It's nice and heavy. We can follow that. When we look at the other inputs to the card, we've got a 0 volts. We've got a 0 volts here, low power, and 0 volts high power, low power. Okay, so when I look at this, I'm not seeing anything relating to CW. It's just high or low power. So I have to assume that high and low power is inclusive of CW. CW would just be superimposed on the RF, and it would be just the high power setting that would control this. And I'm sort of saying to myself, how could this possibly be controlled? And I'm looking here at this particular resistor, 220 ohm resistor, and this capacitor here, C2, which is 100 microfarads. I'm thinking, is there some sort of a charging up or timing bit in the circuitry here? So I thought to myself, how can I get into this and do some testing around here to find out exactly what's going on with this timing? And I realized that this particular part of the radio is practically inaccessible when the radio's together. Even when you've got the chassis frame off the radio and you've got the front and back halves together, you still can't get into this part of the radio to take readings. I could solder flying leads, I suppose, and bring them out. Anyway, so then I moved down to the actual drawing of the card itself, the physical drawing of the card itself. Here it is here. And here's ML1 down the bottom here. And I looked and I looked and I looked and I could not find C2. And in fact, C2 lives just here. Someone's forgotten to put it on the diagram. Believe it or not. There's the input on 6. It goes across to a capacitor that's not shown on the drawing, through the capacitor, through that resistor there, and then onto pin 10. That's it. And I thought to myself, how am I going to get in here and do this testing? Then I had a brilliant idea. I remembered there's a friend of mine, Mark, down in Wagga, also belongs to the Clansman WhatsApp group. And his call sign is Victor Kilo 2WU. And I know that Mark has built a set of extension cables that he can run the back of the radio off the radio on the bench, so he can get access to the back of the radio easily while the radio is still working. He's built these extension cables. So I thought I'd ring Mark up, tell him what I suspect and what my findings have come to, and ask him, could he go into this part of the radio here and in fact do some testing and try and figure out whether to remove this delay, we would either short the capacitor out or increase the capacitor to increase the delay. Mark was really interested in what I was talking about here, and he said to me, next time I've got a radio apart, I'll do that. Well, lo and behold, 6 hours later, he just couldn't help himself. He had to go in and find out how this worked. And he found out, in fact, that by shorting this capacitor out across here with just a simple jumper lead, and luckily the capacitor's post soldered, so it's accessible very easily after taking off a small inspection plate. Yeah, you could, once you shorted that capacitor out, the delay disappeared. And I thought, beauty. So my next step now is to go and have a look at my radio and pull it apart, short out that capacitor, and do some bench testing of my own. Thank you very much, Mark, Victor Kilo 2WU, for your help in this particular project. Let's move to the workshop. Okay, now that we know all that, let's have a look at how we get to this particular capacitor in the to section on the back of the radio. So it's pretty easy. We just simply take all the screws out of the back of the radio and we pull the back off. It's as simple as that. We also make sure that while we've got the back off, we don't turn the rotary switch because it's keyed to the back. A little key just there. So we make sure we don't turn this, and we make sure we don't turn that while we've got these two halves apart. Okay, the little capacitor that we're looking for supposedly lives just underneath this plate. So I'm going to take these two screws out of here and these three screws here that hold this section in, and I'm going to lift that out and have a look inside. Okay, now that I've got the back of the radio removed and the inspection plate taken off, we can see the components inside. There's ML1 there, and there's that little capacitor there that actually really lives. Look, it's not even on the diagram, but there it is. And that's the 100 microfarad capacitor that's causing the timing to drop the radio down to the lower power setting. And that's the number 6 terminal right there, goes across to the capacitor, through the capacitor, up here to the little resistor, through the resistor, and onto pin 10. Okay, and according to Mark, all we've got to do is put a link from that terminal there, a short link to that terminal there. Very easily reversible. So I'm going to do that, put the radio back together again, and see what we have as far as power reduction is concerned. Okay, a couple of minutes with the soldering iron, and I've put a little bridge across this capacitor. Just soldered it on. Yeah, simply can be removed in, well, a couple of minutes if I wanted to do that in the future. So let's put the radio back together again now. Return the plate, all the screws, put the back on the set, and get it back on some testing and see how we go. Okay, we've got the set back together again, and ready to conduct the same test that we did before. I've connected up the dummy load there, got the meter here to measure the peak output voltage. Let's go over the settings. We've got a high power set. We're on single sideband. Got my tone generator set up. So the whole idea now is to see if the power drops down like it did before. So tone on. Okay, let's monitor the output here and see how we go. Okay, here we go. No drop in power. Fantastic. Okay, so that's looking at about 25, 26 watts continual output power out of the set, not dropping down on sideband. Very interesting, very good. Now to put the set back on the air and judge the results. I'm sure that that I'm not going to get that complaint again that says after about 4 seconds your signal drops down and we have a little bit of trouble understanding the final parts of your messages. So yeah, a little easy mod that could possibly improve the performance of your Clansman 320. Thank you guys. This is Victor Kilo 2 Papa Radio Charlie saying 73 for now. Okay, the final thing to do is to test this on the air. So I've just done that, and I've just spoken to a station in New Zealand, ZL3JAS, Jason, and to do this particular test I've put the radio onto my home station antenna, and I've reduced the power from the radio down to about 15 watts by using an RF attenuator, just to sort of reduce my signal and make it just a little bit smaller, so the test would be a little bit more conclusive. And I've just had a very, very long rag chew with Jason in New Zealand, probably 20 minutes, and he's told me that that there's been no reduction in power on the back end of my sentences. So communications has been A1 through all of our QSO. So I'm happy to say that this very, very easy modification seems to be quite a success. Okay, this is Victor Kilo 2 Papa Radio Charlie saying farewell.